This is a presentation on an instructional intervention for proportional relationships by Annika Mackley. The research topic for my capstone was on the impact that manipulatives and mathematical modeling have on students' engagement and mathematical proficiency. The problem I noticed was lower engagement in middle-level math classes. This was impacting student performance in math classes, increasing the number of students not reaching grade level standards. This could be caused by a lack of modeling being taught to students and less hands-on learning present in middle school classes. The two research questions addressed during this study were: how does increasing the use of mathematical models and manipulatives in the classroom impact student engagement? And how does implementing mathematical models and manipulatives in the classroom affect students' mathematical proficiency? The product of the study is a 4-lesson intervention unit on proportional relationships. Each lesson is listed below with its approximate length. On the next 4 slides will be more information on each lesson. Lesson 1 is called Trucks and Boxes. During this lesson, students are engaged in a card sort where they are learning about what ratios and equivalent ratios are. Pictured on this slide are the cards used for this card sort. The goal for this lesson is to have students group the cards into 2 groups, with each having the same ratio of trucks to boxes. More information on this slide of the learning target and what students will be doing are present here. Lesson 2 is called Perfect Purple Paint. In this lesson, students are building on their knowledge of equivalent ratios while also learning how to graph proportional relationships. Students first start by creating equivalent ratios using Unifix cubes and recording their work in a ratio table. Then, guided by the teacher, students label the columns X and Y to help create the ordered pairs they need to graph, including one table from the previous lesson on trucks and boxes. So students will be graphing 2 tables. So then the students both graph both tables, followed by a discussion led by the teacher, where students are guided into discovering the characteristics of a graph of a proportional relationship. Those characteristics are a straight line that passes through the origin. These are examples of the work students are creating from this lesson, including the ratio table, the list of ordered pairs, and the graph. You can also see the work students are doing in the table to find equivalent ratios by the little operations with the arrows. So you can see in the ratio table with the perfect purple paint, students were noticing you can take 2 times 2 to get 4, and then 3 times 2 to get 6. Lesson 3 is called the Lemony problem. This lesson is focused on learning the constant of proportionality, also known as the COP, and using it to write an equation in the form of y equals k times x. This lesson starts similar to lesson 2, with students using Unifix cubes to model their equivalent ratios. However, they are comparing 2 recipes of lemonade with the goal of finding which one will make the lemoniest lemonade. Like the other lessons, students create a ratio table for each recipe and are guided to discover the COP by finding the unit rate for each recipe. The students are then asked to graph the 2 tables on the same graph for easier comparison. The teacher then directs students to identify the COP in the graph for both recipes and model how to write the equations. This lesson is broken apart into 2 days. This slide is an example of students' work for this lesson, including the two ratio tables, the COPs, the equations, and the graph of both recipes. Lesson 4, the final lesson in the intervention, is called Ratio Problem Trade-In. This lesson is focused on students practicing the skills they have learned in the previous lessons. This lesson starts with the teacher showing how to find the COP using the ratio table by dividing y by x. Then the students are given the first problem. Each problem provides one representation of a proportional relationship, and the students have to fill in the missing pieces. When one problem is complete, students come to the teacher to check their work and get the next problem. If any part of the problem is incorrect, the student is sent back to correct their mistakes. There are 6 problems in this lesson for students to practice with, each one increasing in difficulty. This lesson can last around 2 to 3 days depending on the progress of your students. On this slide provides examples of the worksheets provided to students for this particular lesson. The one on the left, students are provided a story to start, and the lesson on the right, students are provided with a graph to start. The methodology for my study was the following. I first gained permission to collect the data. I then chose 12 7th grade students who scored a level 2 on the standardized math assessment in 6th grade as my participants. To address my first research question, I used a qualitative research method, direct observation. And to address my second research question, I used a quantitative research method, comparing test scores from unit quizzes, end of unit tests, and district standardized tests. The data collection tools I used for this study were direct observations, a unit quiz, a end of unit test, and the district standardized math test called the Easy CBM. I used 2 analysis methods for my data to analyze the qualitative data, the direct observations. I used a content data analysis. This is where I organized my observations by common themes I noticed among students. To analyze the quantitative data, the test scores, I used descriptive statistics where I found the mean, median, and mode for each quiz and test score. On this slide is a visual representation of the data collected from the direct observations. The first bar graph on the left is a comparison of how often boredom, confusion, and frustration were noticed among students. One important takeaway from this bar graph would be that confusion was the most observed behavior out of these 3. It is also important to note that frustration was only ever observed while the student was also confused. The second bar graph pictured in the middle is a comparison of on-task conversation, intrigue, and engaged concentration. These 3 behaviors were observed in all students, with intrigue showing the least often and on-task conversation showing the most often. The last bar graph, shown on the right, is a comparison of on-task versus off-task days for each student. 3 students, A, F, and L, never had an off-task day. 9 out of 12 students had 3 or fewer off-task days, and only 3 students, C, D, and E, had 4 or 5 off-task days. On this slide, we have the central tendencies for each assessment given to the students during the intervention. Starting with the pre-test easy CBM, then the quiz, then the end of unit test, and lastly the post-test easy CBM. The color coding of the table is green and white are at grade level. Blue is exceeding grade level. So 8 out of 12 students scored at grade level according to the pretest results, with all measurements of central tendencies scoring at grade level. Students performed the best on the quiz with all students at grade level or above. The average score for the end of unit test was a 3, meaning the average student was scoring at grade level. 7 out of 12 students reached grade level standards at the end of unit test, and the post-test had 11 out of 12 students performing at grade level, with an average score at grade level. So these are the results from the quiz and end of unit test, broken down into 4 levels. Red is below grade level, yellow is approaching grade level, green is at grade level, and blue is exceeding grade level. Each table is accompanied by a pie chart, color-coded the same as the table. No students were performing below grade level on either of these 2 assessments, with the lowest score approaching grade level. This next slide is a comparison of the pre- and post-test results. The table and pie charts have the same color coding as the previous slide. As you can see, there are students in the green and blue categories by the post-test. According to the pre-test, 4 students were either approaching or below grade level. And after the post-test, only 1 student was approaching grade level. All others are at grade level or exceeding. The results of the study are below. The use of manipulatives and mathematical modeling increased engagement, with most students showing high level of engagement throughout the lessons. Students who were observed confused and frustrated were showing signs of productive struggle. There was a positive impact of manipulatives and mathematical modeling on mathematical proficiency as well. Students' performance increased by the end of the intervention, showing 3 more students performing at grade level than before the intervention. So the strengths of the research methodology are targeted problem solving and flexibility, as it gave the ability to adjust lessons as needed in both content focus and timing. The weaknesses of the methodology were limited generalizability and a short time frame. Since the study was focused on 12 of my students, it may be hard to relate the findings of other classes of the same grade level due to changes in population. The timing of the study was also conducted over 10 days, which was not enough time to see the long-term effects of the intervention. The 2 influential factors were the content focus of the intervention unit and the students who were chosen for the study. The content of the intervention influenced the modeling tasks and manipulatives that were used, which heavily influence how the lessons are structured. The students who were chosen because were chosen because they were not performing at grade level, but were very, very close. These students are referred to as bubble kids because they're on the brink of reaching grade level, they're just not quite there yet. And lastly, the following the end of the research, there was a couple areas that could use further investigation. The first area that could be explored further is the effect that mathematical modeling and manipulatives have on other math topics, such as rational number operations and generating equivalent expressions. The second area that I felt could be investigated further is what the best teaching practices and strategies are for engaging middle school students in their math classes, because that is often a hard struggle. Thank you for your time, and I hope you enjoyed this presentation.